Have you ever wondered why speed control in DC motors is so important? Well, it's all about efficiency and optimizing performance. The ability to adjust a motor's speed is critical to the functioning of many devices and systems we interact with daily. From the blender in your kitchen to the electric car on the highway, speed control ensures these machines operate at their best. Now, how is this control achieved? In the world of DC motors, there are three primary methods to manage speed. First, we have voltage control where the speed can be altered by changing the supply voltage. Next is field control, where we adjust the motor's speed by changing the magnetic field strength. Lastly, we have armature control, a method that involves varying the resistance in the armature circuit. These methods each have their unique advantages and applications, and we will delve into them soon. Now that we understand why speed control is crucial, we'll delve into how it works. The first method we'll explore is voltage control. Now, voltage control is a rather straightforward method of controlling the speed of a DC motor. In essence, it involves varying the supply voltage. Here's how it works. When you increase the supply voltage, the speed of the motor also increases. On the other hand, when you decrease the supply voltage, the speed of the motor decreases. It's as simple as that. However, like most things, it's not without its limitations. One of the main drawbacks of this method is that it can lead to a loss of torque, which is the turning force of the motor. Despite this, the voltage control method is commonly used due to its simplicity and ease of implementation. It's a great starting point for anyone looking to understand the basics of speed control in DC motors. That's how voltage control works, but it's just one of the three methods. Next up, we have the field control method. Now, this is a fascinating way to control the speed of a direct current motor. How does it work, you ask? Well, it's all about manipulating the field current. By increasing or decreasing this current, we can effectively alter the speed of the motor. But it's not all sunshine and rainbows. While this method does allow for a wide range of speed control above the rated speed, it has its constraints. For instance, weakening the field strength too much can cause the motor to become unstable. However, the field control method shines in its ability to provide higher speeds without the need for high voltage. This makes it an ideal choice for applications requiring fast, efficient motor operation. Field control offers a different approach to speed control, yet there's one more method to consider. So let's keep moving and delve into that next. Now let's turn our attention to the armature control method. This is another effective approach to controlling the speed of a DC motor. In essence, the armature control method involves adjusting the armature resistance. By increasing or decreasing this resistance, we can effectively control the motor's speed. Imagine you're driving a car. Just as you would use the gas pedal to control the speed of your vehicle, with the armature control method, you're essentially pressing the pedal by adjusting the armature resistance. However, as with any method, there are pros and cons. The armature control method offers great flexibility and ease of use. On the flip side, one of its drawbacks is that it can lead to a loss of efficiency due to heat generated by the additional resistance. So, it's crucial to keep these factors in mind when choosing the most suitable method for your specific application. With armature control, we've covered the three basic methods of speed control in DC motors. So, we've explored the three fundamental ways to control the speed of a DC motor. We've taken a deep dive into the voltage control method, where we manipulate the supply voltage to adjust speed, and it's clear that while it's a straightforward method, it does require careful handling to avoid damaging the motor. We then examined the field control method, a technique that adjusts the motor's magnetic field. This method, though less direct, offers greater precision. However, it also comes with its own set of challenges, mainly the risk of demagnetization. Lastly, we uncovered the armature control method. By altering the resistance in the armature circuit, we can effectively manage the speed. It's a robust method, but it isn't without its drawbacks, such as the potential for wasted energy. Understanding these methods not only gives you control over your DC motor's speed, but also helps optimize its performance and efficiency. Keep asking questions, keep learning, and remember, knowledge is power.